Let's discuss what a parabola is. We'll go through the definition first. A parabola is the locus of a point in a plane which moves in such a way that it is always equidistant from a fixed line referred to as the directrix and a fixed point which will be called the focus, and this particular focus is not going to lie on the directrix. Let's try to understand this graphically. We'll begin by considering two lines that are perpendicular to each other. So as we can see here, we have two lines. Let us call the vertical line, we are going to name this as the directrix. So this is the directrix. Then we have the line which is perpendicular to the directrix. On this line, we're going to consider a point F. The point F will be referred to as the focus. Now this point F which lies on the line, so this line is known as the axis of symmetry. This line will be named as the axis of symmetry. Now what we'll do, we're going to consider a point P on this plane. We're going to consider, let's say this is the point P. Now the position of point P is very important. So this particular position is such that its distance from the focus, or PF is the distance of the point P from the focus F, is going to be exactly equals to the distance of the same point from the directrix. This is going to be the perpendicular distance we have to consider. So let's say the perpendicular line PM is perpendicular on the directrix. Now, wherever we choose this particular point, it is always going to follow the criterion that it is going to be equidistant from the focus as well as the directrix. So let's say if we choose the point to be lying on the axis of symmetry, then this particular point is going to be equidistant from the focus as well as directrix. Now, it's called the locus of a point. So that means wherever we choose the point, let's say we consider all the points lying on this particular plane such that its distance is always going to be equidistant from the focus and the directrix. And when we join the points, when we join all those points, it's going to trace out what is referred to as a parabola. So this is a parabola which is right facing, and as you can see, the parabola passes through the axis of symmetry and it crosses it at a particular point. This point is referred to as the vertex. So it's going to be the vertex of the parabola. So now that we have the understanding of what the directrix and the focus means, now what we'll try to do is derive the standard form of the equation of a parabola. Now, in order to derive the standard form of the parabola, what we'll have to do, we'll have to consider our coordinate axis. So we have already defined this as the axis of symmetry. So let's say the axis of symmetry is coinciding with the x-axis. Now, next what we need is the y-axis. The y-axis will be chosen in such a way such that it passes through the vertex of the parabola. So here we have the y-axis. So this is the y-axis. We have the directrix. Now, since this is the y-axis, this is going to be the origin. So here what we are doing is we are considering the parabola to be having its vertex at the origin. So we need the coordinates of the focus. Now the focus for a parabola, the focus is positioned in such a way such that its distance from the vertex, so OF, that's going to be equals to distance of the point from the directrix. So this, let's call it C. This is the point where the directrix intersects with the axis of symmetry or with the x-axis. So this distance CO is going to be exactly equals to the length of OF. Okay, now we will consider the focus to be at the coordinate point h, 0. There is no y coordinate here. Then we will consider a point P. This is, let's say, this is the locus of the point P having the coordinates x, y. And we have a directrix. Our directrix needs to be having an equation. So since it's a straight line which is passing through the point C and perpendicular to the x-axis, so its equation is going to be given by x equals to a. Now in our case, a value, this distance is nothing but this distance, but it's going to be negative. So it is lying to the left side of the x or y-axis. So x will be equals to negative h. We're going to rewrite this equation in the general form. So we have x plus 0 times y plus h equals to 0. So this is going to be the equation of directrix. We have the equation of the directrix. We have the coordinates of the focus, which is h, 0, and we have that coordinate point P. Now by definition, we know that PF, so if we join P and F, this length is exactly going to be equals to the perpendicular distance of the point P from the directrix. So let's call the line meets the directrix at M. So PF will be equals to PM. Now let's find out the distance PF using the distance formula. So we will use the distance formula. We'll take the square root. Underneath the square root, what we need is the difference of the x coordinate. So that's x minus h whole square. Added to the difference of the y coordinate, so that will be y minus 0. We'll square this value. This will be equals to PM. PM is the perpendicular distance of point P from the directrix. So we'll have to use the formula. We'll take the absolute value. Then in the numerator, we start by considering the coefficient of x of the directrix. So that's 1. 1 will get multiplied to the x coordinate of point P. So that's simply x. Added to the coefficient of y of the directrix, so that's 0. 0 gets multiplied to the y coordinate of point P, so we have 0 times y. And then we add it to the constant term h of the directrix, so that's simply h. Divided by the square root, so we'll take the coefficient of x, that's 1, square this value, and add it to square of the coefficient of y, so that's simply 0 squared. This is going to give us square root of x minus h whole squared plus y squared equals to the absolute value of x plus h divided by 1, that's going to be simply x plus h. So let's square both sides. We get x minus h whole squared plus y squared equals to x plus h whole squared. Rewriting this, we get y squared equals to x plus h whole squared minus x minus h whole squared. So what we have is the difference of two squares on the right hand side. So that will be simply the product of x plus x minus h and x plus h minus x plus h. So here we have positive h and negative h cancelling out. Negative x and positive x cancels out. So y squared will be equals to 2x multiplied to 2h, which is simply equals to 4 times hx. So this is going to be the standard form of a equation of a parabola. So y squared will be equals to 4hx. Right, so this is the standard form of a parabola, and we are considering a right-facing parabola. So now that we have the equation for the standard form of a parabola, there are 3 more forms. So let's discuss all the other 3 forms. So here we have the 3 other cases. So let's talk about the first one. We have the x-axis and the y-axis. We have a left-facing parabola as such that its vertex is touching the y-axis at the origin. Now, the focus is going to be at this particular point F. But we're going to consider the focus to be having the coordinates negative h, comma, k, which means that the distance of the focus from the y-axis is going to be h, but it's negative h because it's on to the left of the y-axis, which means that the distance of the directrix from the vertex will be positive h, with telling us that its equation is going to be given by x equals to positive h. Now, when we solve this, then we're going to get the equation of the parabola is y squared equals to, we'll get a negative sign here, negative 4hx. Now coming to the second parabola, so this is an upward facing parabola. Now here, our vertex is at the origin, so this is the vertex point, which is having its coordinates 0, 0. Now this is going to be the focus of the upward facing parabola lying on the positive y-axis. So let's call it 0, k. If this is 0, k, then the directrix will be at a distance of negative k, or you can say at a distance of k below the x-axis. So its equation is going to be given by y equals to negative k. So when we solve for this particular locus of the parabola, then we're going to get the equation x squared equals to 4ky. And if we consider the other, consider the third parabola here, so this is going to be having its focus at 0, negative k, and the equation of the directrix will be y equals to positive k. In that case, our equation of the parabola will become x squared minus 4 times ky. So now that we have defined the standard form of the equation of a parabola, let's talk about how to find out the coordinates of the focus of any parabola when its equation is given to us. So this is the derivation for finding out the standard form of the equation of a parabola. We've got it, that it was y squared equals to 4hx. Now let's consider this particular parabola. Let's say we have a parabola with the equation y squared equals to 12 times x. Our goal will be to find out the coordinates of the focus. What we'll do, we're going to compare this with the standard form, which we have already derived, with y squared equals to 4hx. Now when you compare it with the standard form, then we obtain 4h will be equals to 12, which means that the value of h equals 12 divided by 4, so that's 3. Now the coordinates of the focus will be, so let's go to our diagram. We have already defined the coordinates of the focus, which is given by h comma 0. So that means our coordinates of this particular parabola, coordinates of focus of this particular parabola will be h comma 0, which corresponds to 3 comma 0. So that's going to be the coordinates of the focus. Now what about the equation of the directrix? We can also define the equation of directrix once we have the value of h. The equation of directrix for this right facing parabola will be given by x equals to negative h. So that means x must be equals to negative 3, and this is going to be the equation of the directrix of the parabola with equation y squared equals to 12x. Now what about the coordinates of its vertex? The coordinates of its vertex is very simple whenever our equation of the parabola is given in the standard form, because this is in the standard form, y squared equal to 4hx. So here the coordinates of the vertex is always going to be at the center, that is 0 comma 0. Next what we'll do, we'll define another term. It's referred to as the latus rectum. Now a latus rectum is a straight line, or you can say it's a line segment which is going to pass through the focus of the parabola. And also there's a criterion that it's going to pass through the parabola and it is going to be parallel to the directrix. So here we have the directrix. Our latus rectum is a line segment which is going to pass through the focus and is going to be parallel to the directrix, with the condition that its endpoints meets the parabola. Okay, so the endpoints are at the parabola. Now our goal will be to find out the length of this latus rectum. Now clearly this is the point P which is lying on the parabola. Now our point P, let's say it has the coordinates x comma y. Now we know that the equation of this parabola, we have already defined it as y squared equals to 4 times h times x. Fine. Now what is the x coordinate of this point P? The x coordinate of this point P is nothing but the distance of the focus from the origin, which has a length of h. So here we can replace the value of x with h, which gives us y squared equals to 4 times h, or simply put y squared will be equals to 4h squared. Now when we take the square root on both sides, so y will be plus or minus 2 times h. So that means we'll consider the positive value 2h because we are in the first quadrant. So that means coordinate of point P will be h comma 2h. Or in other words, we can say that this length is going to be 2h. If this is length is 2h, then by symmetry this length is also going to be of 2h. Or that means our length of the latus rectum of the parabola, that's going to be equals to 4 times h. Or we'll take the absolute value because we're considering the length. So whatever be the value of h, we multiply with 4, and this is going to give us the length of the latus rectum. Translations of parabola. So when we started out, we considered the standard form of a parabola given by y squared equals to 4h times x. Now here the coordinates of the vertex is always at the origin whenever we have a parabola given by this particular equation. Now what if the vertex is not at the origin but at some other core point having the coordinates, let's call it a comma b. Then in that case what we'll do, we are going to rewrite the equation. Then instead of y squared we will write it as y in upper case, so y squared will be 4 times h times x. This is going to be the equation of the new parabola. Now here the values of x and y are such chosen that x corresponds to x minus a and y corresponds to y minus b. We've shifted the origin actually. Hence the new equation of the parabola, so we're going to use this particular equation. In place of y, we're going to replace with y minus b whole squared. The multiply equals to 4h times x, but x will be x minus a. So this is going to be the new equation of the parabola. So let's try to understand it. So earlier we had the x-axis and we have the y-axis. Now in this case, this is the origin 0 comma 0, but this time instead of this origin, let's say this is the point through which the parabola vertex lies. So this is going to be the vertex of the parabola, let's say at A comma B. In that case, we have to draw a line which passes through the vertex and parallel to the x-axis. So this is going to be the new axis of symmetry. We have the new axis of symmetry, and then equation of the directrix is going to change. So let's consider the original equation of directrix whenever our parabola's vertex is at the origin. So that was given by x equals to negative h. But what we'll do for the new directrix will be such that all we have to do is first replace the value of x with uppercase x. So x becomes equals to h, but in place of x we're going to use x minus a equals to negative h, or we can say x will be equals to a minus h. So that's going to be the equation of the new directrix. So let's say this is our new directrix. Roughly this directrix has because it will be shifted to the right hand side, its equation will be a minus h. And we'll have the focus. The focus was earlier at h comma 0. So if this were earlier, the focus, so let's discuss the focus of the parabola. So focus was earlier at the point h comma 0. So the new focus will be, since it has moved to the right hand side by a amount along the x-axis, we will get x plus a. And it has moved above in the positive y direction by b units, we have 0 plus b. Or we can say that the coordinates of the focus f, the new focus, will be h plus a comma b. So this is how we can translate a parabola. This is going to similarly work for the other three parabolas. So let us apply all of these ideas in solving few numerical problems. So in this problem, we need to determine the equation of a parabola whose focus is at the point negative 3 comma 2, and the directrix is given by the equation x plus y equals to 4. Let's try to find out the equation of the parabola, which means that for simplicity we'll consider a line having the equation x plus y equals to 4. This is going to be the directrix. So we take a line which is going to be perpendicular to the straight line, that's the axis of symmetry, and on this particular line, let's say we have the focus f with coordinates negative 3 comma 2. Now we're going to consider a point P with coordinates x comma y. We can join point P and point F. That's going to give us the distance PF. So PF will be equals to the square root of, where this is where we are using the distance formula. We have x minus of minus 3, so we get x plus 3. Square it and add it to the difference of the y coordinate squared. We get y minus 2 whole squared. Next, let's label this as number 1. Next, we are going to drop a perpendicular from point P on the directrix, and let's say it meets at point M. Here, PM is going to be perpendicular to the directrix, so that means we can easily find out the perpendicular distance of point P from the directrix. So PM will be given by absolute value of, so in the numerator, what we'll do, we'll take the coefficient of x. So let's write it in the general form. So we have x plus y minus 4 equals to 0. Here coefficient of x is 1 and the coefficient of y is 1 as well. We'll take the coefficient of x, which is 1, and multiply it to the x coordinate of point P. So that's going to be x. Add it to, now we will take the coefficient of y of the straight line. So that's also 1. This will get multiplied to the y coordinate of point P. So we have y minus 4, because that's the constant term that we need to add, divided by the square root of, now what we'll do, we'll take the square of the coefficients of x and add them to each other, sum of squares. That's what we need in the denominator. So PM will be equals to x plus y minus 4 divided by square root of 2. Now in the problem itself, it's we are being asked to find out the equation of parabola. Now from definition, we know that these two distances PF must be equals to PM, because the point P is going to be equidistant from both the focus as well as the directrix line. So let's square it. So PF squared will be equals to PM squared, meaning we're going to equate equation 1 and equation 2. On the left hand side, we have x plus 3 whole squared added to y minus 2 whole squared. This will be equals to, squaring PM gives us x plus y minus 4 whole squared divided by square root of 2 squared. That's simply 2. Okay, let's further simplify. Now we have x squared plus 6x plus 9 added to y squared minus 4y plus 4. This will be equals to, so let's do one thing. We're going to cross multiply with this 2 on both to the expression on the left hand side, and that leaves us with x plus y minus 4 whole squared. When expanded, we get x squared plus y squared plus 16 plus 2 times xy minus 8y minus 8x. So here we have on the left hand side 2x squared plus 12x. So 9 plus 4, that's 13. 13 times 2 will be 26 plus 2y squared minus 8y. That will be equals to x squared plus y squared plus 2xy minus 8x minus 8y plus 16. Now we're going to combine all the terms. So 2x squared minus x squared, that will be positive x squared. 2y squared plus minus y squared will be positive y squared. Then we have 12x. This will be added with 8x, giving us 20x. Then we have negative 8y and negative 8y, so that gets cancelled out. And we have negative 2xy, so this is transposed to the left hand side. And then finally we have 26 minus 16, that corresponds to 10, equals to 0. So this is the general equation of the parabola, whose focus is at the point negative 3 comma 2, and the equation of the directrix is given by x plus y equals to 4. Now clearly, if we try to have a understanding of the equation, here we're getting x squared plus y squared. It does not look like the standard form that we have obtained. Now, if we look at the equation of the parabola that we have obtained, this does not look like the one that we obtained for the standard form. Our standard form gave us something of the form y squared equals to 4hx. Now this is not having this particular form. The reason behind this is this only works if the vertex is at the origin. So clearly this means that this particular equation of the parabola tells us that its vertex is not going to be at the origin. So here I have used the graphing calculator to plot the graph of the parabola as is obvious in this diagram. So this is going to be the vertex. Clearly we can see this is the origin 0, 0, but our vertex is not passing through the origin. That's why we're getting an equation of the form x squared plus y squared, this is x squared plus y squared minus 2 times xy plus 20x plus 10 equals to 0. This was the equation of the parabola that we obtained. So its vertex is not going to be at the origin, but at some other point. So that is why our equation was not looking familiar to the form x squared equals to 4ky or y squared equals to 4hx. It was not having the same form. These two forms tells us our parabola is at the vertex of the parabola is at the origin, whereas this particular equation of the parabola tells us that its vertex is somewhere which is not on the origin. Let's do another problem. So this time we have a parabola which focus is at negative 3, 0. That means this time our focus is going to lie along the x-axis. So the axis of symmetry is the x-axis. So this is where, let's say, this is our y-axis, and our focus is lying at the point negative 3, 0. Our goal will be to determine the equation of the parabola such that its directrix has the equation x plus 5 equals to 0. Okay, now x plus 5 equals to 0, this corresponds to x equals to negative 5. So here our directrix is going to lie to the left of the focus, which means that this is actually a right facing parabola but not a left facing parabola. That means our parabola is going to look something of this particular form. And let's try to find out the equation of the particular parabola. All we have to do is consider the general form. So here we will start by considering this is our directrix with the equation x plus 5 equals to 0. We have a line which is perpendicular to the directrix. On that particular line, which is referred to as the axis of symmetry, we have the focus having the coordinates negative 3, 0. We're going to consider a point P with the coordinates x, y. And we will equate the distance PF with the distance perpendicular distance PM. So PF will be equals to PM. So PF can be, so let's square it. PF squared will be equals to PM squared. PF, here we can use the distance formula to obtain x plus 3 whole squared added to y minus 0 whole squared. So this is 0. That will be equals to pm squared. So that will be, we'll have to take the coefficient of x, which is 1, multiply it with the x coordinate of point P. Add it to coefficient of y of the line, so that's 0. So it's 0 multiplied to y, plus the constant 5 of the straight line divided by, so here we have 1 squared plus 0 squared. We've already taken the square. So here we get x plus 3 whole squared plus y squared equals to x plus 5. So this is going to be, so what we have done here is we have taken the absolute value and thus we have squared this result. So that should give us x plus 5 whole squared. Now we have x squared plus 6x plus 9 plus y squared equals to x squared plus 10x plus 25. Now here x squared and x squared gets cancelled out. So we have y squared equals to, we'll transpose 6x to the right hand side to get 4x. Then 25 minus 9, that's going to be 16, which gives us y squared equals to 4 multiplied to x plus 4. So here now we have in the standard form y squared equals to 4hx. Now here we can observe that the x value is not x but x plus 4, which tells us that the x coordinate of the vertex has shifted by -4 units. So we now have the equation of the parabola given by y squared equals to 4 times x plus 4, whose focus will be at the point -3, 0, and the directrix given by x plus 5 equals 0.